There are places in this universe where the laws of physics stop working, not slow down, not behave differently. Stop. There are regions of space so empty that if you placed our entire galaxy inside them, you would see nothing in any direction for hundreds of millions of light years. No stars, no galaxies, no light. Just silence that has lasted longer than complex life has existed on Earth. There are objects so massive that the light trying to escape them has been traveling toward the exit for millions of years and has not gotten any closer. There is something invisible pulling our galaxy and 100,000 others toward it at 600 kilometers per second. We cannot see it. We cannot identify it. We can only measure what it is doing to everything around it. And there is a boundary, a line in space approximately 46.5 billion light years away in every direction. Beyond it, the universe exists. We simply cannot see it and never will. Not because of technology, because of physics. The light from what lies beyond that line will never reach us. Whatever is out there is gone forever. These are not theoretical constructs. They are confirmed locations, real coordinates, real measurements. By the end of this video, you will understand exactly what 8 of the most terrifying places in the observable universe actually are, and why the scariest one is not the most violent or the most massive. It is the one that is completely, permanently, and mathematically invisible. In 1981, astronomer Robert Kirshner was conducting a survey of galaxy positions when he found something that should not exist. A region of space approximately 330 million light-years across containing almost nothing. Not fewer galaxies than expected, not a sparse region. A region where the expected thousands of galaxies have been replaced by approximately 60. Where the large-scale structure of the universe, the web of filaments and galaxy clusters that defines the cosmic architecture, simply is not there. It is called the Boötes Void. To understand the scale, consider this. Our galaxy, the Milky Way, home to between 100 and 400 billion stars, would be alone inside the Boötes Void. The nearest neighboring galaxy would be further away than the entire diameter of the void itself. You would have to travel 330 million light-years in any direction before finding another galaxy. That journey at the speed of light would take 330 million years. The void is real. The emptiness is measured. The explanation remains incomplete. The current best model suggests it formed from the merging of smaller voids in the early universe through gravitational processes. But the scale of the Boötes Void challenges the models of how matter distributed itself after the Big Bang. A void this large should not have had time to form, given what we understand about the rate of cosmic structure formation. It is called the Great Nothing. And in a universe that should be filled with structure everywhere, a region this empty is not just unusual, it is a structural anomaly that has not been fully explained in 44 years of trying. In 2004, astronomers examining the cosmic microwave background, the faint afterglow of the Big Bang that permeates all of space, found a cold spot, a region of the sky in the constellation Eridanus that was measurably colder than its surroundings, not by a small amount, by enough to be statistically significant in data that should be nearly uniform across the entire sky. Further investigation revealed that the cold spot corresponds to a region of space approximately 1 billion light-years across with far fewer galaxies than should occupy a volume that size. The Eridanus Supervoid, the largest known void in the observable universe. The leading explanation connects the two observations. A void this large would cause photons passing through it to lose energy through a process related to the expansion of the universe, producing exactly the kind of cold spot observed in the microwave background. But the cold spot is colder than this explanation fully accounts for. The mathematics work partially, but not completely. The discrepancy is small enough to be dismissed and large enough to remain in the literature as unresolved. Some physicists have proposed that the cold spot is the imprint of a collision with a parallel universe during the very early cosmos. This is not the consensus position, but it is a published, peer-reviewed hypothesis, not a theory from the internet, a calculation. The Eridanus Supervoid is a billion light-years of almost nothing with a cold shadow in the oldest light in the universe that we cannot fully explain. And the explanation we cannot fully rule out involves another universe hitting ours. In the 1970s and 1980s, astronomers noticed something that made no sense. Our galaxy was moving, not the orbital motion around the galactic center, not the motion of the local group through space, a directed motion, our galaxy, and hundreds of thousands of others all moving toward the same point at approximately 600 kilometers per second. Something was pulling them, something massive enough to redirect the trajectories of hundreds of thousands of galaxies across hundreds of millions of light-years of space. And it was hidden. The Great Attractor sits in a direction of the sky called the zone of avoidance, the region blocked by the disk of our own galaxy. The stars and dust of the Milky Way prevent optical telescopes from seeing what lies behind it. For decades, the source of the gravitational pull could not be directly observed. Radio and X-ray observations eventually revealed the Norma cluster, a massive concentration of galaxies, as a significant component of the structure generating the pull. But the full picture remains incomplete. The gravitational influence is larger than the visible mass can account for. And more unsettling, the Great Attractor itself may be moving towards something larger. The Shapley supercluster, a concentration of mass approximately 650 million light-years away, may be pulling the Great Attractor the same way the Great Attractor is pulling us. We are being pulled towards something. That something is being pulled towards something larger, and we cannot see the full chain. Supermassive black holes at the centers of galaxies are terrifying but predictable. They sit in known locations. They have known masses. They behave according to known gravitational dynamics. Rogue black holes do not. When massive stars die in supernova explosions, the resulting black holes can receive a gravitational kick from the asymmetry of the explosion. That kick can be large enough to eject the black hole from its parent galaxy entirely. Once ejected, it drifts through intergalactic space without any attachment to any structure. No galaxy, no star cluster, no detectable position. Black holes do not emit light. They can only be detected when they interact with matter, bending light through gravitational lensing or disrupting nearby gas and stars. A rogue black hole drifting through empty space produces no detectable signal. It is invisible until it is close enough to affect something. In 2022, NASA confirmed the first probable detection of a rogue black hole approximately 5,000 light-years from Earth, detected through the gravitational microlensing of a background star. It is estimated that millions of rogue black holes drift through the Milky Way alone. Millions. In our galaxy, in unknown positions, moving in unknown directions. If one were on a trajectory toward our solar system, the first indication would be gravitational disturbances in the outer planets. By then, the timeline for any response would be measured in centuries at best, and there would be no response. There is nothing to do about a black hole. TON 618 was first cataloged in the 1950s as a faint blue point of light in a survey of stellar objects. In the 1970s, astronomers realized it was not a star. It was a quasar, a galaxy whose central black hole is consuming matter at a rate that produces more light than the combined output of every star in the galaxy. A quasar outshines its own host galaxy by orders of magnitude, and TON 618 is not a typical quasar. The black hole at its center has a confirmed mass of approximately 66 billion solar masses. For comparison, Sagittarius A star, the supermassive black hole at the center of the Milky Way, is 4 million solar masses. Ton 618 is 16,500 times more massive. The event horizon of Ton 618 is approximately 1,300 astronomical units across. 1 astronomical unit is the distance from Earth to the Sun. The event horizon of Ton 618 is 1,300 times that distance. Our entire solar system, including all planetary orbits, fits inside it with room remaining. Ton 618 is 10.4 billion light-years from Earth. We see it as it existed 10.4 billion years ago, a few billion years after the Big Bang. In the time that light has been traveling from Ton 618 to our telescopes, the Sun has completed approximately 45 orbits of the galaxy. The object we are looking at when we observe Ton 618 no longer exists in its current form. What it has become in the intervening 10.4 billion years is unknown. A neutron star is already the most extreme stable object physics permits to exist. The compressed remnant of a massive star, approximately 20 kilometers across, containing more mass than the Sun. A teaspoon of neutron star material weighs approximately 1 billion tons on Earth. A magnetar is a neutron star where something went differently during the collapse. The magnetic field did not simply survive the supernova, it amplified to approximately 1 quadrillion times the strength of Earth's magnetic field, the strongest confirmed magnetic objects anywhere in the observable universe. At that field strength, empty space itself becomes unstable. Virtual particle pairs that normally flicker in and out of existence throughout the vacuum get physically separated before they can annihilate each other. The vacuum tears. Light itself behaves differently near a magnetar because the fabric of space it travels through has been structurally altered by the field. In December 2004, a magnetar designated SGR 1806-20 fired. In half a second, it released more energy than our Sun produces in 250,000 years. The burst reached Earth from 50,000 light-years away and measurably compressed our ionosphere. Every gamma-ray satellite in orbit was instantly saturated. Ships and aircraft experienced communication blackouts on the night side of Earth, all from a dead star the size of a city on the other side of the galaxy. The nearest confirmed magnetar is 9,000 light-years from Earth. There are estimated to be hundreds in the Milky Way that we have not confirmed because they have not fired while we were looking. Their positions are unknown. Their activity is unpredictable. The only warning of a giant flare is the radiation itself traveling at the speed of light. The warning and the event are the same thing. The observable universe extends approximately 46.5 billion light-years in every direction. This number requires explanation because it seems impossible. If the universe is 13.8 billion years old, how can we see 46.5 billion light-years? The answer is that space itself expands. The regions that emitted the light we are currently receiving have been moving away from us the entire time that light was traveling toward us. They are now much further than they were when the light left. The edge of the observable universe is not a wall, it is a horizon, the furthest distance from which light has had time to reach us since the Big Bang. Beyond it, the universe continues. Stars exist, galaxies exist, structures exist. We will never see them, not because of technology, because of physics. The expansion of space beyond a certain distance exceeds the speed of light. The light from objects beyond the cosmic horizon is being carried away faster than it can travel toward us. It will never arrive. Whatever exists beyond that boundary is causally disconnected from us forever. And the boundary is shrinking. As the expansion of the universe accelerates, driven by dark energy, more and more of the observable universe will eventually recede beyond the horizon. Galaxies that are currently visible will eventually disappear, not because they were destroyed, but because the space between us and them expanded beyond the point where communication is possible. In the very distant future, a civilization in our galaxy will look out and see nothing. Not a dark universe with no stars. A universe whose other galaxies have all receded beyond the horizon. A universe that provides no evidence of the Big Bang because even the cosmic microwave background will have redshifted beyond detectability. They will look out and see an empty cosmos, and they will be wrong about everything. These 8 places share one property. They reveal the shape of the universe, the actual geometry of what exists, and that geometry is stranger than anything that happens inside it. The universe is not hostile. It does not aim anything at us. It does not know we exist. It is simply vast and old, and structured in ways that make us a temporary arrangement of matter in a region of space that will eventually become too isolated to know where it came from. Subscribe to BrainDrop if this is the kind of content that changes how you think about where you are. And tell me in the comments, which of these 8 places do you think is the most terrifying? Not the most violent, the most terrifying. I want to read every answer.